This is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today we'll be discussing on topic called as Study of Economic Minerals on Chlorite, Galena and Pyrolusite. So if you remember in the previous lectures, we have already discussed about the economic minerals. We have started with different economic minerals. Along with this, we are going to study 3 more economic minerals which are very much important as economic point of view. So economically, it's very important in the industries and all. So that we'll be discussing today. So let us start this lecture today. So in this lecture, we are going to discuss at least 3 minerals which are economically, it is very much important in the industrial field as well as the economic field. So we'll be discussing this lecture starting with the chlorite. So what is a chlorite? So chlorite is a clay mineral. Basically, it's a clay mineral and that's commonly found in the metamorphic rocks. So it's a clay mineral means the mineral will be very much soft and it is basically found in the metamorphic rocks. So I hope you remember what is a metamorphic rock. Metamorphic rock is formed by the heat and pressure formation of igneous rocks or sedimentary rocks or metamorphic rock itself. And it is also present in the sedimentary rock too. So sedimentary rocks also, I hope you remember what is sedimentary rock, which is formed by the sediments. Now composition, if you see, so composition here is hydrated iron, magnesium, aluminium silicate. It has a high iron content and it has a magnesium present in that, and always also aluminium silicate is also present in that. Now appearance, if we see, so it looks like appearance of green in color and it is a foliated kind of mineral and or a platy texture, often with a pearly luster. So if you see this appearance of this kind of chlorite mineral, it has a pearly kind of luster and it has a texture of platy and foliated green color. And general physical properties, if you see the general physical properties here, so color of this mineral is, it varies from pale to dark green, sometimes grayish or blackish in color, and the luster will be vitreous to pearly. So the luster of this kind of mineral is either vitreous, either to pearly, and the streak of this this chlorite will be greenish to white. So if you remember what is the streak of a mineral is, basically streak means when the mineral, when we try to make it in a powder form. So what is the basic color of that we call it as streak, or as once we try to streak it on the streak plate and then with the color which we get, that color we call it as streak of the mineral. Now transparency of this mineral is translucent to opaque. So this mineral is basically, the transparency will be in a translucent way and it looks in an opaque color, and cleavage of this mineral is perfect basal cleavage like mica. So it has a platy kind of like a texture and it comes in a flakes like mica, and fracture uneven to slightly flexible. So the fracture is uneven to slightly flexible here. Now, when you go with the economic importance here, so what is the economic importance here? So basically, as we are discussing about the economic minerals, so it has a major economic importance in the industry. So it is used in the construction materials and coatings, sometimes mined for the magnesium and the iron content, and commonly found as the alteration product and hydrothermal deposits. So it is found in the alteration products, in the hydrothermal deposits, and occurrence here if you see, so found in the metamorphic rocks, hydrothermal veins, and as an alteration product of the mafic mineral. So what is mafic here? So we have discussed many times in the previous lectures, mafic when it is rich in the magnesium and iron. So that we call it as mafic. Now chloride, basically it looks like this. So it comes in a pale to greenish color. So sometimes it will be this color, sometimes different kind of colors we may see based on the content, the mineral content, based on the composition of this mineral, the color varies here. Now, but even though the color varies here, the streak of this color will be same. So application of the chlorite here. So chlorite is a group of silicate minerals commonly found in the metamorphic rock. So its chemical compositions varies, but it generally includes magnesium, iron, and silicon, and it has a various industrial, geological, environmental applications here. And when you talk about the geological and petrological applications, so it is an indicator mineral in the metamorphism. When you apply it in a geological and petrological applications, basically it's an indicator for the mineral in the metamorphism. Chloride is often used to determine the metamorphic grade of rocks, particularly in the low to medium temperature environments. Rock strength analysis, its presence affects the mechanical properties of rocks, especially in structural geology, geotechnical engineering. So, this application is basically when you talk about the geological and petrological applications, when you talk about the strength of the rock. So, its presence affects the mechanical properties of the rock, especially in the structural geology and the geotechnical engineering. Now, soil formation and clay minerals, chlorite weathers into clay minerals, contributing to the soil fertility. And when you come to the industrial applications, second thing is industrial applications, as it's an economic mineral. So it's widely applicable in the industry, like ceramics and refractories. So due to its heat resistant properties, chlorite is used in the manufacturing refractory bricks and the ceramics. So it is also used as a filler material. So finally, ground chloride is used as a filler in the paints, rubber, plastics to improve its durability, and as a construction material added to the cement and concrete for the strength and the stability. Now, third thing, when you talk about its application in the environmental field. So as a chloride, when we are apply this mineral in environment, so it uses in the water purification, soil remediation, air pollution and control. So as a water purification, chloride compounds such as sodium chloride are used as a water treatment. So it is also used to treat the water and to disinfect and remove the contaminants from the water. Now, so as a soil remediation, helps to stabilize the contaminated soils by binding heavy metals. Air pollution controls used in the scrubbing systems to remove the toxic gases from the industrial emissions. Now, as a medical and chemical application, so disinfectants and bleaching agents. It is used as sodium chloride is used to reduce chlorine dioxide, strong disinfectant and the bleaching agent for the paper and the textile industry. And as an alternative medicine here, so some controversial uses include chloride-based solutions for the supported health benefits, but these are not medically approved. Now coming to the second type of mineral here, that is galena. So galena is a primary ore of lead. So it's a primary ore of lead and has several industrial, technological and scientific applications due to its high lead content and metallic properties. So it's a primary ore of lead and it has several industrial and the technological applications, and the composition of the galena here is lead sulfide. And appearance here is metallic gray, high density, cubic cleavage. And economic importance, if we see the economic importance here, so primary ore of lead, essential for batteries, radiation shielding and ammunition. So this is a primary ore of lead which is used in the batteries as well as in the radiation shielding, and often contains a silver, making it is important in the silver ore. So occurrence here is found in the hydrothermal veins, sedimentary deposits as a replacement mineral in the carbonate rocks. Now this is how the galena looks like. So it's a primary ore of lead. And metallurgical applications, if we see, so lead production, the main source of lead is for the various industries, as alloying lead from the galena is used in alloys like soldering and pewter metal alloy made of tin, bearing metals, battery manufacturing, solid acid batteries for automobiles, backup power systems, and electronics and radiation shielding, X-rays radiation shielding. Lead to derived from the galena is used in the protective gear and as a hospital X-ray rooms and the nuclear shielding. And a cable thing like protects electrical cables from corrosion and the mechanical damage. As a glass and ceramic industry, so lead glass and crystals so adds brilliance and durability to the optical glass, and is a decorative crystal, ceramic glazes and pigments used in the traditional pottery for a glossy finish, ammunition and firearms, bullets and short pellets. Lead from galena and used in the ammunition manufacturing. Chemical industry, lead compounds used to produce lead oxide, lead sulfides and other chemical derivatives for batteries, paints and the pigments. Now coming to the third mineral, we call it as pyrolusite. So pyrolusite MnO2. So pyrolusite, basically the composition of the pyrolusite is a manganese dioxide. So it contains manganese, so it's a very economic mineral, and it is also important as a industrial point of view. So appearance of this pyrolusite is black to steel gray. So when you see the color of this pyrolusite, so it looks in a color of black to steel gray, soft and powdery to crystalline appearance. And the general physical properties, when you talk about the general physical properties of pyrolusite, so it has a general property. Chemical formula of the pyrolusite is MnO2, and the color will be black to steel gray, and the streak of this pyrolusite will be black or bluish black. So streak means this streak is basically when you make the pyrolusite in a powder form, so the color and appearance of this kind of the streak of this powder form will be black or bluish black. Luster here, so metallic to dull, so earthy in the fine grained forms. Transparency is opaque. So here the transparency of this pyrolusite is opaque, and the crystal system is tetragonal. Now, as an economic importance, so economically it's very important in the industrial field. So it's a primary ore of manganese. So because it has a manganese dioxide composition, so the primary ore is as manganese it is used, and it's a crucial in steel making. It's very crucial in steel making. And as a battery component, steel making as in a battery component used in the glass making and water purification. So pyrolusite is also used in the glass making, and also it is used in the water purification. And the occurrence of this pyrolusite, it is found in the sedimentary and secondary oxidation zones of manganese rich deposits. So sedimentary rocks, as it is rocks which are formed by the deposition. So in the sedimentary rocks, these are basically found in the secondary oxidation zones where the manganese rich deposits are present. Now this is how the pyrolusite it looks like in this color, and basically when you try to streak it, so basically the streak of this pyrolusite will be black to bluish gray. And the applications, when you talk about applications, basically, so as a metallurgical application, it has a wide application in the steel production. So used as a source of manganese. So this is used as a source of manganese in steel making to improve the strength, hardness and the resistant to corrosion. So it is basically used as a source of manganese. Pyrolusite is used as a source of manganese in making the steel. So it is used in the steel making and to improve the strength, basically for the strength, for the hardness and the resistance to the corrosion. It is also resistant to the corrosion. And as a ferroalloy is essential for producing the ferromanganese and silicomanganese, which are used in alloying steel and the cast iron. And aluminum alloys enhances the corrosion resistance of the aluminum alloys. Now, in the chemical industry, how it is applicable? So In the chemical industry, oxidizing agents, so used in the chemical reactions as a strong oxidizer, and especially in the organic synthesis, battery production, key component of dry cell, alkaline batteries, example zinc, carbon, and the alkaline batteries. Now, third thing here is glass and ceramics, so acts as a decolorizer in the glass making by removing the greenish tint caused by the iron impurities, and it is also used in the ceramics as a coloring agent too. And water purification, so pyrolusite is also used as a water purification. It helps in removing the iron hydrogen sulfide from the water supplies. So as a environmental and catalytic applications here, so as a catalysis used as a catalytic converters and various oxidation reactions in the chemical industries, and as a wastewater treatment, removes heavy metals and organic contaminants from the industrial wastewater. And when you talk about the other uses of pyrolusite, so it is used as a welding rod coatings. It is used in the welding of rod coatings, used in welding electrodes, and to enhance this arc stability. Lithium-ion batteries. So it is also used in the lithium-ion batteries, investigated for use of cathode materials for the rechargeable batteries, and medicinal laboratory use. So used in some of the pharmaceuticals and laboratory as a reagents for analytical chemistry. So these are the three types of economic minerals which we have studied. So these three minerals are very important in the industrial field as an economic point of view. That's why it is called as economic minerals. So these are the references you can just go through to find out the more content about this kind of minerals like chlorite, galena, and the pyrolusite. You can just go through this book to find out the more content about this topic, and you can just get more information about it. So let us stop this lecture today. So that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.